All right. So when it comes to synthetic substitution, synthetic division, and long division, there are certain cases where they work, and some are better than others. So remember, when we're looking at doing long division in general, please tell me everyone in here learned long division. Okay, cool. There was literally a girl when I was in high school who had never seen long division before. Like, legit never seen it before, and when we did this, like, she freaked out. Because we're like, dude, it's 4th grade. Like, you should have seen this. Alright, so when it comes to long division, let's say you're dividing 3 into the number 247. Okay? The first thing that you go through and do is you try to see if you can divide 3 into 2. Alright? Now, since I can't do that, because 3 is obviously bigger, I'm going to go 3 into 24. So put a little X here so you can keep everything ordered. And I know I can fit 8 3s into 24. Yes? So 8 times 3 is 24. I write my 24 down here and I subtract. I get 0. Drop down to 7. Alright, how many 3s can I fit within 7? 2. Alright. 6 minus remainder of 1. So typically when you write your final answer, you would write like 82 remainder 1, right? Anybody else's elementary school teachers taught them that? Alright, typically what we should be doing is writing it as 82 and 1/3, where it's 1 over what I'm dividing by. Alright. So when it comes to long division, if you feel like as you go through and do this, you can't keep them straight up and down, because let's be honest, that's kind of difficult. Sometimes you start drifting one way or the other. You can flip your paper sideways and use the blue lines on a lined sheet of paper to keep you where you belong. Okay? Because, did you write this bad boy down? This is what we're starting with. Alright. So, we're ready to actually get this show on the road? First one's never pretty. Alright, don't freak out. They're not that, you have to go slow and you have to make sure you're doing exactly what I show you. Alright, so I'm going to write 9a minus 6, my giant division bar, 9a to the 4th minus 78 a cubed plus 102a squared minus 81a plus 32. Alright, am I missing any terms in that polynomial? No, it goes 4, 3, 2, 1, nothing. Alright, that's important to check, and I believe the next one I have a gap on it on purpose because you have to put a placeholder in for it. You have to put a 0 in. Alright. So, here's what we've got. When you go to do this, you need to treat the minus 6 like it's the annoying younger sibling who's stuck coming along for the ride. Bryce? Okay, but now during notes is not the time. I'll fix it when we're done, okay? I know, honey, it's okay. We can do that here in a minute. This is more important. Alright, so how many 9a's go into 9a to the 4th? Any ideas? Not really. All right, so what I can do to get 9a to be 9a to the fourth is I can multiply it by a cubed. Okay? So a cubed is what I'm going to multiply both of these terms by. All right, and you'll notice I color code line by line so you can see where everything's going, and if you want colored pens, you can grab them. All right, so I'm doing 9a to the fourth minus 6a cubed. Put it in parentheses, and we're going to subtract. So what happens with my 9a to the fourth? It cancels. That's exactly what I want. All right. Now the stupid 6 that's our annoying younger siblings, I have to take that with it. So I have to make sure both of these terms are down here. Because this cancels, and I'm left with negative 78a cubed plus 6a. Always put it in parentheses, because if you don't, you will forget to distribute that negative, and everything will go horribly, horribly wrong. Okay? So, what is negative 78 plus 6? Negative 72. So I've got negative 72a cubed. Now I got to drop this bad boy down. Plus 102a squared. So, my next question is, what can I multiply 9a by to make it a negative 72a cubed? 8a squared, yep. Because 9 times 8 is 72. Oh, actually want to make that a minus. 8a squared. All right, whatever your term is right here when it comes to positive or negative, you want to make sure that term follows right up here, okay? Minus, draw my bar, negative 8a squared times 9a gives me that negative 72a cubed. All right, and then what is negative 8a squared times negative 6? I heard murmur. 48. How many a's? 48a squared. All right, so it's a positive 48a squared. Yes? Bueno? Ooh. What happens right here? What happens with the 72s? Yeah, they cancel out. All right, that's exactly what I want them to do. I want them to keep canceling. All right, so now I'm left with, what's 102 minus 48? I think it's 54, yes? Okay. So now I got 54a squared. Bring my 81 down to the right. What do I need to multiply 9 by to make it be 54? 6. All right, so I need a positive 6a. Okay, my 54 is positive. I need to put a plus in front of that 6. We kind of getting the feel for it. Anybody in here like knit or crochet? No, nobody does that. It's basically, you're following the same pattern over and over and over again. You're just trying to get rid of stuff. So, minus 54a squared minus 36a. So what's negative 81 plus 36? 45. Drop down my 32. And I am almost done. Oh yeah, negative 45. All right, so final thing that I'm plugging in, what do I need to multiply 9a by to get it to be a negative 45a? Just negative 5. And then I got negative 5 times negative 6, so that's plus 30. And then I have 32 minus 30. So your remainder is 2. Okie dokie. Final answer for this, and I'm running out of space, is going to be a cubed minus 8a squared plus 6a minus 5 plus 2 over 9a minus 6. This is why I don't like widescreen TVs, because I work down, not wide. How'd it go? Not as bad as we were expecting? Want one more? Okay. Now I gotta find it, because I moved it. Entire page, where'd you go? Here it is. God, no, not that. Just, how do I copy and paste you? Cut, add a new page. You go. Okay, it's all screwy still, but I don't care. So, if I go back and do this one, do you guys want to try it on your own and see kind of how it goes? Or are you still kind of freaked out by it? Do you want me to help you at least set it up? Okay, so what term am I missing before I start writing anything? X squared. Okay, so if I am missing an x squared, you need to put 0x squared in. So when I go to do my division, 9x to the 4th minus 9x cubed plus 0x squared minus 45x plus 48. Have to make sure you have that blank part in there. So do we want to try it? We'll yell if something has gone awry. Okay. Alrighty. So far so good? And both of these things cancel. Yes? So sweet. I can drop down my 0x squared. Alright. And my minus 45. Alright, but do I really need to try and get rid of this thing right now? So normally what'll happen is you will end up getting something right here. Like let's say it's a negative 2x cubed. Alright, normally you would get something and then you would have to drop down your x squared, but since there's nothing there, we don't need to drop this down right now because it has no purpose. It's gone, right? So I can drop down my negative 45 and my 48 because this has nothing we need to worry about getting rid of. He has no friends. All right? So I get to skip all the way over to here What do I need to multiply by 9x by to get it to be negative 45x? Yeah, negative 5. So I'm going to put a negative 5 right here. All right. And what ends up happening? What do I get for a remainder? I think I get 3. Yes? So, this one needs to have a friend right here for me to actually have to deal with it. If there are no friends, cool, we get to skip them. But you want to keep that placeholder in because the vast majority of the time there will be a friend. So, final answer is going to be x cubed minus 5 plus 3 over 9x minus 9, right? Yay, we've learned long division. Now, synthetic division, once I show you that, you're going to be like, I want a synthetic division, all of the things. Problem is, synthetic division does not work on all of the things. So, you can't have a not equal 1 in this case. You have to make sure whatever is in front of that variable is a 1. That's the only time you can actually use synthetic division. Ready? Draw a giant L on your page. So, here's what happens. Whatever this is right here, we change the sign and we put it over here. Whatever my coefficients are, I put those on that first line, but do I have any missing? No, so I'm cool. I can put a 1, I'll put a negative 16, positive 57, positive 47, minus 39. Your first step is always drop down Alright, drop down this first spot, put a 1. Okay? What is 1 times 7? Put a 7 right here. What is negative 16 plus 7? Negative 9. What is negative 9 times 7? Negative what? 63? Those are super quiet this morning. Alright. Multiply them, put them right there. So what is 57 minus 63? Yeah, negative 6. Negative 6 times 7. Yeah, negative 42. What is 47 minus 42? 5 times 7. 35. Put my 35 right here. 39, well, negative 39 plus 35 gives me what? Negative 4. This right here is your remainder. All right. Your final answer is going to be, let me move him out of the way. Your final answer is to kick your polynomial down 1 degree, because I divided everything by a k, right? So instead of it being k to the 4th, my next one's going to be k cubed minus 9k squared minus 6k plus 5 plus a negative 4 over k minus 7. Weirdest way you've ever seen to solve it? Now you can totally use long division on these. I'm just telling you there's another way. I personally like this way for these because when we start going into graphing, you will have a calculator part of your test and a non-calculator part. Like we do our test over 2 days. Okay, so that way, you guys have to know this. Alrighty? You want to try one on your own? With water wings when you need it? Okay. Here's my next example. Am I missing any terms? No. So I'm cool. Draw my giant L. What do I put on the outside of my L? Yep, positive 2. And then everything inside is 1, 6, negative 13, negative 4. How'd I go? Yeah. Final answer. Well, it's not x, it's a. A squared plus 8a plus 3 plus negative 8 over a minus 2. Woot. Woot. All right. Last thing we're doing is the remainder theorem, which is also called synthetic substitution. So you're using the steps that you had for synthetic division, but you're using it to substitute in x equals negative 4 to that monstrosity of an equation. Okay? This would show up on a no calculator part to your test. It would be one problem. All right? So, the difference is we do not change this sign. Okay? Everything else kind of follows the same. Do I have any missing terms? Nope. Do you guys need a minute to keep copying? Ready? So, if I have no missing terms, I'm literally just copying the numbers like I did earlier. 6, 28, 12, negative 10, and 21. Now, the thing I really want is right here. This will give me my answer. All right, of what happens when I plug in negative 4. All right. Does someone want to test it on their calculator and plug in negative 4 every time they see an x in that polynomial? All right, Sabrina's checking it for me. All right, ratio. Okay, make sure you put parentheses around it when you go like 6, negative 4 to the 4th in your calculator. Drop down my 6. Negative 24. I did get -3. What do we think? It's pretty dope, right? You're like, where has this been my entire life? Like, why am I just now seeing this? Gotta force you guys to do it the old-fashioned way. But that's synthetic substitution, aka the remainder theorem, because what it says is the remainder, what you get right here, is what you would actually get when you plug it in. For some odd reason, it has two names. So that's it for 4.3. We good?